So now that we know how to solve logarithmic functions, let's talk about how to graph logarithmic functions. Let's take a look at the logarithmic function log base a of x. Remember that we swapped x and y. This is equal to the inverse of y equals a to the x. Y equals a to the x. And y equals a to the x had a domain that was all real numbers and a range that was y is greater than 0. Remember on inverses when we swapped domain and range? That means that the domain is now x is greater than 0 and the range is all real numbers. Now we're going to eliminate this problem. Sorry about that. That should never have been on the paper in the first place. I'm going to rewrite it as f of x is equal to the log base 2 of negative x plus 3. Like that, negative x plus 3. So we're just going to rewrite that problem. Well, what we're recognizing is that our function, our argument right here, x, has to be greater than 0. Well, what I did in this problem is I transformed it. I moved it to the right 2 places. Now you should know that if I took a domain and I moved it to the right 2 places, which by the way doesn't have a horizontal asymptote anymore, it has a vertical asymptote, and the vertical asymptote would be x equals 0, that if I am moving this 2 to the right, my vertical asymptote is going to move 2 to the right as well. But let's prove it mathematically. By making this the new argument, remember the argument of the function right here, by making this the new argument, I can say x minus 2 has to be greater than 0, which means that if I add 2 to both sides, x has to be greater than 2. My domain, instead of x is greater than 0, is x is greater than 2 because I moved it 2 to the right. My range is still going to be all real numbers. My vertical asymptote, instead of being x equals 0, is going to be x equals 2. Do you recognize that's related to the shift that happened? Well, let's take a look at this one. This particular problem, it's actually moving it left 3 and then flipping it over the y-axis. So that's going to be a little different. So let's set negative x plus 3 is greater than 0. We're going to subtract 3 from both sides, and we get negative x is greater than negative 3. Well, that makes sense. We moved it left 3, but now we're going to flip it over the y-axis. When we flip it over the y-axis, that changes to positive, this changes to positive. What happens to symbol right there? It becomes x has to be less than 3. Now, my vertical asymptote is at x equals 3, but it's going to actually, if I was graphing it, here would be my vertical asymptote, 1, 2, 3, and my graph, instead of being flipped over the y-axis this way, it's going to be, let me see if I can get this to draw right. It's going to be graphed like this. Okay? And it's going to be x is less than 3 with a vertical asymptote at x equals 3. Now, absolute value functions. Absolute value functions are actually very different because that's always greater than 0, except for one location. Absolute values are always greater than 0 unless they're equal to 0. So instead of saying x minus 1 is greater than 0, because it always will be when it's absolute value, I'm going to say let's not let it be 0 either. Well, that means that x cannot be equal to the number 1. So the domain of this problem is x such that x is not equal to 1. The range, still all real numbers.